Okay, now good morning students. This is Uncovering Chemistry from Joy Varghese. Now in video 5, today we are going to discuss the remaining rule, that is rule number 3. Okay, now in this rule number 3, generally the oxidation number of what we call it as the oxidation number of oxygen in most compound is -2. Okay, but there is an exception. What is the word? There is an exception in this assigning oxidation number. That is, in certain compounds, the oxidation number will be different. Now, what is that? You can see here. That is certain exception. What we say? No, in case of peroxide and superoxide. What is the word? In case of peroxide and superoxide, the oxidation number, I write like this, O dot N, oxidation number of oxygen is in peroxide it is -1 and -1/2 in superoxide respectively. Okay, so in peroxide and superoxide, if you see here, in peroxide it is -1 and in superoxide it is -1/2 respectively. Now, what is the meaning of that? Now, when we talk about peroxide and we talk about superoxide, yeah. So peroxide, you know, H2O2. You must have heard about hydrogen peroxide. What is the word? Hydrogen peroxide. Then sodium peroxide, Na2O2. Okay. Same way here, when you write superoxide, the superoxides are KO2, potassium dioxide, and RbO2, rubidium dioxide. If you have heard about. Now, in this case, the oxidation number of oxygen is -1. Okay, while in this case oxidation number of oxygen, that is in superoxide, oxide is -1/2. What is it? -1/2. Okay, so now suppose when I write H2O2, right? So in H2O2, hydrogen oxidation number is +1, because this is not in free state, it is in combined state with oxygen, and here oxygen will be -1. But we know there are 2 atoms of hydrogen and 2 atoms of oxygen, so this same thing can be written as here +1 into 2, and in for O2 -1 into 2. Okay, so +2 and -2 total, the average oxidation number, what we write now, what is the word I am talking about? Average oxidation number of any compound, what we have seen till now of any compound. So average oxidation number will be what we call it as 0. So here see, it will be 2 into +1 is +2, plus 2 into -1 is -2. So +2 and -2 total average oxidation number is 0. But this is just what we will be studying in the later on unit. But what I want to say in this case, that is the oxidation number of what we saw here. The oxidation number of oxygen is -2 in peroxide. Now same thing when I write for superoxide. So this is example 1 and this is example 2 for that explanation, and for what you call it as KO2 when we write, right? So KO2, it will be what? It will be -1/2 it will be, okay, and potassium it is +1. So 2 into -1/2, it will be what? Equal to here the total, it will be +1 and this will be -1. Okay, total average oxidation number will become 0. Understood? That way also you can check this. So I think this part is clear. So this is for this one is for peroxide and this one is for superoxide. In peroxide, oxygen oxidation number is -1 and in superoxide it is -1/2. So this is one exception what we see. Okay, then another one exception is there. In some cases, I'll just rub this. You can write down this, what we call exception, okay, in your fair book. Now one more example is given there. Okay, this was exception number 1 what we discussed. Now we will talk about exception number 2. One we already discussed. Now exception number 2 I am talking about. In exception number 2, when oxygen is bonded to fluorine, remember this thing, when oxygen is bonded to fluorine. Clear? So when oxygen is bonded to fluorine, we know that fluorine is the most electronegative element. Okay, fluorine, for example, if I take OF2 like this, understood? What I'll take here, OF2, understood? So this name of this compound is the name of this compound is oxygen difluoride, what we say. So in this case, if you see OF2, just a minute, oxygen difluoride, and another example is also there, O2F2, that is dioxygen difluoride. Okay, from the formula only you can make why the di word is written, because of this two. Okay, so now in this case, when we say in this case fluorine is the most electronegative element. Okay, fluorine is the most electronegative element. So what will happen in this case? It will have oxidation number as -1. It will not leave its oxidation number. Understood? So when I talk about OF2, fluorine, it is -1 into what we call it as 2. So in this case, oxygen will have +2 oxidation number. Understood? So this is another exception, means when more electronegative, see, fluorine is also electronegative, oxygen also electronegative, but fluorine is more electronegative than oxygen. So in this case, fluorine will have its -1, at that time oxygen will have +2, what we call. Okay, now in this same case, when we say O2F2, okay, fluorine will have -1 valency, but here 2 oxygens are, to balance it, oxygen will have +2 valency. What is that? Oxygen will have +2, that is, sorry, +1. Oxygen will have +1 oxidation number. This part understood? So oxygen in O2F2 will have oxidation number +1, while oxygen in OF2 will have oxidation number +2. Understood? So this is the exception, another exception number 2. This you can write down in your fair book. One more exception is there for oxygen. The oxygen number of hydrogen in most, sorry. Okay. Now these are the 2 exceptions for oxygen what we have seen till now. Okay. Now in the next part we will be seeing about hydrogen oxidation number, but there is also what we call it as certain exceptions are there. Okay. So these 2 exceptions you can write down in your fair book. This will come in rule number 3 what we call. Okay. Next. Okay. Now rule number 4 what I am talking about, it's about hydrogen. That is the oxygen, the oxidation number of hydrogen in most compound is +1. Okay, but there is an exception in this also, exception. Now what is that exception? What we say, that is with when it is in metal hydride, means when the hydrogen is bonded, when hydrogen is bonded to metal. What is the word? When hydrogen is bonded to metal in binary compound. binary compound means two, two atoms. Binary, two types of elements are used in that. Means example, when I say, okay, in binary compound, the oxidation number of hydrogen, see generally it is +1, but when it is bonded to metal in binary compound, the oxidation number of hydrogen is -1. Okay, so this is an exception. Means what? For that we will just go through few examples. That is example number 1. When I write, suppose here, lithium hydride, when I write sodium hydride, okay, then another calcium hydride, CaH. Understood? So in all these cases, hydrogen oxidation number is -1. In all the cases, hydrogen oxidation number is -1. Hydrogen oxidation number is -1. Okay, all these three cases it is -1. Understood? So don't forget this. In metal hydride, that is in binary compound. Means what? If I want to write this, suppose if I write lithium hydride, lithium hydrogen will -1, lithium +1. Sodium, when I write sodium hydride, what it will be? I think CaH2 will be there. Okay, because calcium +2. Okay, now in this case sodium +1, hydrogen -1. Calcium, when we write calcium, it is +2. So to balance that, it will be -1 only, but 2 into -1 it will be. Understood? So in this case, all in metal hydrides, what we call hydrogen oxidation number is -1, while in other all cases, what we call oxygen, it is what we call +1. Means what? Where it is +1, what I said, in most of the compound means water molecule. If I give an example of water molecule, hydrogen it is +1, oxygen -2. Okay, so most of the compound it is +1, but an exception is there. When hydrogen is bonded to metal, the oxidation number of hydrogen will be -1. Okay, so this is rule number 3 and 4. So we will stop here. Next time we'll continue with the other rule. Okay, so whatever rules we have written today, that is of oxygen we saw and of hydrogen, certain exceptions. Oxygen we saw 2 exceptions, that is peroxide, superoxide, that all what we saw, and with the fluorine what we saw. Understood? When it is combined with fluorine. Okay, then for hydrogen we saw generally it is +1, but when it combines with metal it is -1. So this all exceptions and rules you write down, continue that what you have written in video number 4. Okay, so we'll continue it later. Okay, so the remaining rule we will be doing it in next video. Okay, thank you very much.